In this video, we're going to be looking at examples of how the equilibrium constants of related reactions are themselves related to one another. So, just to review, if I have a given chemical reaction and I reverse it, so I swap the reactants and the products, then to get my new equilibrium constant, I just take the inverse of the equilibrium constant of the original reaction. If I have a chemical reaction and I multiply it by a constant, then to get the new equilibrium constant, I just take the original equilibrium constant and raise it to the power that I multiplied the equation by. So in this case, I multiplied my original equation by 2, and so I raised the original equilibrium constant to the second power. And if I have two reactions that I can add together to get a third reaction, right, so I'm going to add these together because AB appears on both, because 2B appears on both the products and the reactants, it'll cancel out. So any two reactions that I can add together to get the third reaction, I multiply their equilibrium constants. So let's look at a couple examples. All right, so we're given this chemical reaction and we're given its equilibrium constant. And so now I have a new reaction and I want to know what is its equilibrium constant. And so we can see the difference between the two reactions is that in this new reaction, I've just multiplied the old reaction by 1/2. So that means that the new equilibrium constant is equal to the original equilibrium constant raised to the 1/2 power. So K2 is going to be 650 to the 1/2, or the square root of 650. So K2 is going to be 26. All right, so we have the same original reaction, and now I want to know what is the equilibrium constant for this new reaction. And so you can see I've got, in the new reaction, I've got N2 in the reactants, whereas in the original example, it's in the products. So I flipped the reaction, and also I've multiplied the original reaction by 2. So my new equilibrium constant, because I flipped it, I'll have 1 over the original equilibrium constant. And then because I multiplied the whole thing by 2, I'll raise it to the second power. So my new equilibrium constant will be 1 over 650 squared. And so when I calculate that, the number that I get is 2.4 times 10 to the minus 6. All right, in the final example, I have two reactions where I'm given the equilibrium constants, and I would like to know the equilibrium constant of this third reaction. So I'm going to have to rearrange these first two and then add them together to get this third reaction. And so I usually do this systematically. So in my new reaction, I need an O2 on the reactant side. So I look in the reactions I'm given and where do I have O2? So O2 only appears here. So I'm going to need to flip this reaction to get O2 on the reactant side. So I'm going to rewrite this guy as O2. All right, now the next thing I need is an oxygen atom on the reactant side. And so the only place I have the oxygen atom is on this one. So I'm going to need to flip that guy. And so I'll rewrite that as all right, and so when I add these together, my NOs will cancel, my NO2s will cancel, and I'll be left with O2 plus O going to O3. So by manipulating the given reactions the way that I did and then adding them together, I do get the third overall reaction. And so what I need to do is figure out what is the K for these two reactions and then multiply them together. So for this first one, I had to reverse K2. So the K for this reaction is 1 over 5.8 times 10 to the minus 34. And that's equal to 1.7 times 10 to the 33. The K for this reaction is 1 over 6.8 times 10 to the minus 49, or 1.5 times 10 to the 48. So to get the equilibrium constant for this reaction, where I've added the first two together, I just need to multiply their equilibrium constants. So the K for this reaction is 1.7 times 10 to the 33 times 1.5 times 10 to the 48. And so I get the equilibrium constant to be 2.6 times 10 to the 81.